Hi class, welcome back to our Science 8 session. Today, we're going to do a fun and creative review activity based on what we've already learned about atoms. This activity is called Atom Talk, What's on Your Mind? And it's your chance to show what you remember and understand about atoms in your own creative way. Let's begin with a quick question to activate your memory. What do you already know about atoms? You can submit your answer using the QR code I'll provide in a moment. Thank you everyone for your creative and thoughtful submissions. I really enjoyed seeing how you expressed your understanding of atoms. You all did a great job reviewing the key concepts. Now, before we wrap up, let's take a moment to recall the evolution of the atomic model, something we discussed in our previous lesson. Scan this QR code to answer a few questions about the different atomic models and the key scientists behind them. This will help you recall what we've discussed in our previous lessons. Alright class, now that we've reviewed the basics and the evolution of the atomic model, it's time to take a deeper dive. I'm going to give you a video link that you'll need to type into your browser or click from the chat. This video will help you visualize what's really happening inside an atom, something we'll explore more in our next activity called Inside the Atom, a closer look. While watching, I want you to really focus on the following: how the atomic model has changed over time, what each part of the atom does, how scientists discovered these parts, any new terms or concept you hear. Take notes if you need to. This video will help you understand the next activity better. Welcome back. I hope that gave you a clear picture of what's happening inside an atom. Now to check your understanding, please scan this QR code or click the link in the chat to answer a few short questions about the video. Take your time, but try to finish within the next 10 minutes. This will help prepare you for our next activity. How subatomic particles interact in an atom. Atoms are made up of three main subatomic particles: protons, neutrons, and electrons. These particles interact through fundamental forces that keep the atom stable. Protons and electrons attract each other because they have opposite charges. Example, like how a magnet sticks to your refrigerator. Opposite charges pull together. Protons and neutrons stick together in the nucleus because of a strong force. Example, think of them like bricks held tightly by superglue to build a strong wall. Neutrons help balance the atom. Example, like a seesaw. Neutrons help balance the atom. Example, like a seesaw. If one side is too heavy, like too many protons, it tips over. Neutrons help keep it balanced. Where do we see atoms in real life? Water is made of atoms, two hydrogen atoms and one oxygen atom, or H2O. Salt is made up of sodium and chlorine atoms. Your body is made up of atoms like carbon, oxygen, and hydrogen. So even though atoms are super tiny, their parts work together to build everything we see, touch, and use every day. Now let's move on to our next activity called Atomic Matchup, know your particles. But before we begin, I want to make sure you're fully prepared. To help you understand the next activity better, I need you to watch a short video that explains the roles and characteristics of the three main subatomic particles. Now that you've watched the video, it's time to test your understanding. Scan this QR code or click the link in the chat to access the activity. Take your time but try to finish within 10 to 15 minutes. Let's see how well you know your particles. Please take a screenshot of each slide after clicking the word check. Then send all your screenshots directly to my messenger as proof that you completed the video activity. Class, let's think about this question. Why do subatomic particles behave the way they do? Inside an atom, there are three main parts. Protons, they have a positive charge. Neutrons, they have no charge or they're neutral. Electrons, they have a negative charge. Now here's the fun part. These particles don't just sit still, they move and interact because of forces. Let me explain. Protons and electrons attract each other because they have opposite charges. That's why electrons stay around the nucleus. They're pulled in by the protons. Protons repel each other because they have the same charge, but they don't fly apart because neutrons help hold them together using a strong force called the nuclear force. Electrons move around the nucleus in energy levels. They don't fall into the nucleus because they're moving fast and have energy that keeps them in place, kind of like how the moon orbits the Earth. So in simple words, subatomic particles behave the way they do because of their charges and the forces between them. These forces keep the atom stable and working properly. Our next activity is called Particle Profiles. Meet the atom's tin. In this activity, you'll get to show what you've learned in a fun and creative way. You have two options for this activity. Choose the one you like best. Option 1. Creative drawing. Draw your chosen subatomic particle, whether it is proton, neutron, or electron, on a bond paper. Use symbols, colors, and labels to show its charge, location, and role in the atom. Be creative. You can add a face, accessories, or anything that represents its personality. Option 2. Monologue or poem. Write a short monologue or poem from the point of view of your chosen particle. Imagine you are the proton, neutron, or electron. Talk about your job, where you live in the atom, and how you feel about the other particles. Important reminders. Use bond paper for your output. Write your complete name, grade level, and section at the bottom of your work. After finishing, take a clear picture of your output. Send the photo directly to my messenger as your submission. Great work, class! I really enjoyed seeing your creative outputs for particle profiles meet the atom's tin. You brought those tiny particles to life in such fun and imaginative ways. Now let's move on to our next activity called Atoms in Numbers and Stories. We'll start with part 1, Math Connection. In this part, we'll apply what we know about atomic structure to solve a simple math problem. Don't worry, I'll show you an example first so you'll know exactly what to do. Now, it's your turn to solve a few problems like this. Please follow these instructions carefully. Get a 1/2 crosswise sheet of paper, solve the problems that I will give you, show your complete solution, write your complete name, grade level and section at the top of your paper. After answering, take a clear picture of your paper, send the photo directly to my messenger as your submission. Great job, class! You've just finished solving problems using what you know about atomic structure. That was part 1 of your activity. Now let's move on to something more creative. For part 2, literacy connection, I want you to use your imagination. You'll write a short paragraph using a metaphor to describe an atom. Think about it like this. If the atom were a house, where would the protons, neutrons, and electrons be? What rooms or places would they stay in? How would they behave in that space? Get a 1/2 crosswise sheet of paper. Write a short paragraph, at least 3 to 5 sentences, using the metaphor of a house to describe the atom. Be creative, but make sure your paragraph shows your understanding of where each particle is found and what it does. Don't forget to write your complete name, grade level, and section at the top of your paper. After writing, take a clear picture of your work, send the photo directly to my messenger as your submission. I'm excited to read your creative ideas. Let's see how well you can turn science into a story. If you have any questions, feel free to ask. Alright, Science Explorers, that wraps up our class for today. You did an amazing job, from solving atomic problems to bringing particles to life with your creativity. Remember, atoms may be tiny, but your ideas are mighty. Whenever you drew, wrote, solved, or imagined, you've just taken another step in becoming true young scientists. Don't forget to send your outputs and screenshots to my messenger. I'm super excited to see your work. Until next time, keep exploring, keep asking questions, and always stay curious, because in science and in life, the smallest things can make the biggest difference. See you in our next class. Stay safe, stay smart, and stay atomazing. Bye for now!